In this tutorial, we will introduce the concept of molecular symmetry. Molecular symmetry is an important concept since it's the key to understand molecular orbital theory and different types of spectroscopy. To get started, let's talk about the two fundamental concepts of symmetry. The first one is symmetry operation. A symmetry operation is an operation which moves a molecule or an object into a new orientation that is equivalent to the original. We can use this gummy bear as an example. Assuming we move the gummy bear in different fashions, the operation that gives us the original gummy bear back will be a valid symmetry operation. The second concept is symmetry element. A symmetry element is a point, plane, or axis of reference about which a symmetry operation is performed. Overall, we have 5 basic symmetry elements, and each of them has a corresponding symmetry operation. The first symmetry element is a plane. The corresponding symmetry operation is a reflection. Going back to the gummy bear again, if we look closely, we can see that there is a reflection plane at the very center of the gummy bear. A reflection about that plane leaves the original object unchanged. We have a water molecule. If we look closely, we see that there is a reflection plane that cuts through the center of the water molecule. If we reflect hydrogen atom A and hydrogen atom B across that plane, the orientation of the water molecule remains unchanged. We can also see another plane of reflection that contains all 3 atoms. If we reflect all atoms across the plane, everything remains the same. The second symmetry element is a center of symmetry, which is associated with the operation inversion. To visualize inversion, let's look at a benzene molecule. In a benzene molecule, we can see that there is a center of symmetry. If we swap places of the carbons and the hydrogens across each individual carbons and hydrogens, the molecule remains unchanged. The third symmetry element is an axis, which is associated with rotation. Rotation is symbolically expressed as Cn, where n is the number of folds of rotation. To find what n is, we simply divide 360 degrees with the angle of rotation. Here we have the water molecule again. We can see that in a water molecule, there exists a rotational axis going through the oxygen atom. To rotate the molecule so that the orientation of the molecule remains the same, we have to rotate 180 degrees around the rotational axis. To find the number of folds of rotation, we simply divide 360 degrees with 180 degrees, which gives us a number of 2. So formally, we can say that the water molecule possesses a C2 axis of rotation. The fourth element is an improper rotational axis, which is associated with the improper rotation. The improper rotation is a combination of a rotation, then a reflection across a plane that is perpendicular to that axis of previous rotation. We symbolically express the improper rotational axis with Sn, where n is the number of folds of rotation. To show an example of that, let's look at methane. In methane, there exists an improper rotational axis. Notice that the rotational axis is perpendicular to the plane of reflection. We can first rotate the molecule by 90 degrees around that axis, then reflect the molecule across the plane that is perpendicular to the axis of rotation. The end product of this operation is equivalent with the original. We initially rotated the molecule by 90 degrees. The number of fold of rotation is 360 divided by 90, which gives us 4. So here we can formally say that we have an S4 rotational axis. This symmetry element is typically difficult to visualize, But it is important to know that in this operation, we have to first rotate the object, then reflect the object across a plane that is perpendicular to the axis of rotation. The last symmetry element is the identity. The operation associated with it is simply not operating on the object at all. Every molecule possesses the symmetry element of identity. So, by the end of this tutorial, I'm hoping that you will have a basic understanding of the 5 essential symmetry elements and their corresponding operations. To summarize, in this tutorial, we learned to visualize reflection, inversion, rotation, improper rotation, and lastly, the identity. If you're struggling to visualize these operations, go to Symmetry at Otterbein, where many interactive practice problems are available. Thanks for watching.